going to go ahead and get started. First of all, I want to welcome everyone. My name is Shelly Troyer from iTech. Welcome to this week's edition of Tech Tips Live. If this is your first time joining us, Tech Tips Live is a weekly series that we're going to be doing where we're going to be sharing information about the tools and services, how-tos, and innovative ways to incorporate technology into your daily workflow. The series will be every Wednesday at 3 p.m., so make sure you tune in each week to stay on top of technology here at K-State. What I'm sharing here on the screen is our Tech Tips Live website that we have created. You can go here to find information about upcoming sessions as well as get the recordings from previous week sessions. So if you go to one of these previous weeks and click on it, you can find the recording down there. A few housekeeping items. We're going to try to save questions until the end. So I have muted everyone's microphone, but if you do have a question at the end, feel free to go ahead and unmute yourself and speak up and ask the question, or you can use the chat box and send those questions in at any time, and then I will just ask our presenter to answer those questions for us. So at this time, I'm going to go ahead and pass it over to this week's presenter, Javel Rohn for the Media Development Center here in iTech. So Javel, I'm going to have you take it away.
All right. Thanks, Shelly. I appreciate the introduction. And again, my name is Javel Rohn. I am the media coordinator here at Kansas State University. I'm also a technology trainer here, so you may see me in some of the ETDR overviews and things like that. But I did want to talk to you today mainly about 3D printing. We partnered with the Friends of the Library and iTech. We kind of make collaborative efforts to kind of purchase a 3D printer. We knew that that was something that was happening, something that was new here on campus, and that a lot of students were interested in. And so we jointly with the Friends of the Library were able to come up with an idea for students and faculty and staff in order for them to have access to something like that. So with that being said, I'm going to go ahead and share, because I figure you guys may want to see some actual 3D printing going on. So I'm going to share my other camera so you guys can watch along as we're actually printing an object here. And then I'm going to go ahead and start my screen share so you guys can kind of tune in that way. All right. Okay. So we're just going to talk a little bit about 3D printing and the possibilities. Again, my name is Javel Rohn, and I'm just going to take you guys just kind of behind the scenes here of what we do here at Hill Library. The main things I'm going to talk about and what this is all about is, how does 3D printing work? What are the types of 3D printings? Environments for 3D printings. What type of environments do we want to create for 3D printing? How Kansas State University is using this technology. So these are a few things that I'll cover today, and then I'll introduce very special guests. So how does it work? A lot of times people want to know, how do you get an object just seemingly out of thin air? It seems like something from almost like Star Trek or, Back to the Future. It's kind of futuristic in that sense. But it's a really simple process, and I'm going to explain it through this infographic here. Just hope you guys can kind of see that. Let's see. All right. So I'm just going to talk a little bit about how 3D printing works. Okay, let me open that back up. Okay. So to give you a visual, an object is either scanned by a 3D printer, or the 3D specifications are entered into a computer application. That's like a computer-aided drafted application. Once that object is scanned, the specifications are generated. And the easiest way for me to explain to some is it's basically, if you've ever been to the deli, right? You go in and you want to have a ham sliced. That's exactly how 3D printing works. So imagine you giving a full ham to your deli and asking them to slice it for you. It slices it into these really thin layers, and then it sends that information to the printer. Now, the cool thing about having a printer is that they don't give you the sliced ham back to you in slices and say build that. But that's exactly what a 3D printer does. It just stacks these 2D layers on top of each other. So essentially, we're printing out 2D layers and stacking them, and then it's kind of creating this 3D object. So it's a really, really neat process to watch. I hope you guys are kind of getting a chance to view and see just how we're using 3D printing here. But we have PLA is our material that we use. It's a biodegradable, non-toxic plastic. It's made from a corn sugar, believe it or not. And when it burns, a lot of people say it gives off kind of a waffle smell. The hardware that we're using is the MakerBot 5th generation. And the reason why we chose the 5th generation, it was kind of in between. It was not necessarily the industry standard for 3D printing. However, it wasn't something that was cheap in purchase. It was something that we felt would produce the quality that we wanted, and then it will also allow us to kind of survey to see who would be interested in using this here in Hale Library, who would be interested in using this in the Media Development Center. And so we purchased the MakerBot 5th generation, which we've had pretty good success with. And so there are two types of files mainly that we use for 3D printing. That is a stereolithography file and an object file. The big difference between the stereolithography file is the stereolithography file does not measure color or texture. An object will retain that information, so it will keep the color and it will keep the texture of that specific file. So this is similar to that of like a JPEG or a picture file, or a PDF. When you kind of see these visual formats, this is a 3D format, if you will. So you have STL and OBJ. These are the most common file types that you see when dealing with 3D printing, and these are the file types that work best with the MakerBot 5th generation. Okay, so I'm just going to move along and just kind of talk about the types of printing. And I'm not going to spend too much time on this, but I do want to at least hit on this a little bit so that we can kind of better understand just what types of printing are being done to generate 3D objects and models. The first method is the MakerBot. You can kind of see the MakerBot 5th generation here. It's a Cartesian method. This method is one of the most widely used methods, and it uses kind of a linear pattern. So you have a y-axis, an x-axis, and a z-axis. The z-axis is actually this build plate here. So if you can kind of see this build plate, this will be the z-axis, and it moves up and down. You also have the extruder, which is up here, and it moves kind of left, right, and backwards and forwards. So it kind of gives you this really linear pattern when you're printing out, or when you're printing out your objects. So it's a very consistent type of printer, but it's also limited in some ways. And the other type of printer is the delta and polar printing. This is growing in popularity. So this has a fixed z-axis or a fixed build plate. And the delta, the cool thing about the delta is it kind of works like a spider. You know, if you would imagine a spider coming down the web, it can move in any type of motion. So it can move in a circular motion, it can move in an up-down motion. And so it has a lot of versatility as far as how it prints out shapes. So this circular motion is really neat, and so it's a lot faster in some ways. And with the polar printing type, you can actually, the build plate, the z-axis rotates. So it can go up and down, it can print in a circular motion, and the build plate actually rotates. So if you think about it kind of like the old pottery classes where you're forming an object, it kind of works very similar to that. And then lastly, you have your DLP, which is a resin-based printing using projections and UV lighting. And this is more of the newest printing. I don't know if you guys saw the TED Talk with the Carbon 3D, where they actually presented this type of printing where they're using UV and digital lighting projections to actually generate 3D objects. And it's a really neat process to watch. And at this time, Carbon 3D is not partnering just quite yet, but that is something that we have talked about. So it's a really, really cool thing. So these are the different types of printing. But one thing I wanted to talk about was what's happening here and the environment here for Kansas State University and 3D printing. So at Kansas State University, the 3D printer is being used for cancer research and development. In May of 2015, Dr. Victor Chikhan printed an electromagnetic coil prototype that will be used to help in the fight against cancer. Dr. Chikhan shared how exciting it was to be able to print out parts at a less expensive cost in plastic, then later determined just how to approach printing the coil in silver for future use. For more information on this groundbreaking research, you can read Cancer Treatment and Drug Delivery with the Help of Magnetic Nanoparticles. And this is Dr. Chikhan. Another cool project was with a senior student who is now alumni. His name was Andrew McVeigh. This past April, he graduated in engineering, and he's also a teaching assistant in the Department of Medical and Nuclear Engineering. And he was featured on Reddit for his semester project using our 3D printer. So I know you guys are excited to find, are wondering what groundbreaking and world-changing thing Andrew created. And just to kind of show you, I know he's a mechanical and nuclear engineer, so I know it's going to be something cool, right? He actually made a Settlers of Catan game expansion pack, right? So this was his senior project. This was something that he worked on. He wanted to figure out how to use his space so that his parts and things like that would not be, sorted everywhere, and a better way to compartmentalize his cards and material, right? Now, to most of us, it is groundbreaking and it's phenomenal, right? But the cool thing, it was actually featured on Reddit in May of 2015, and it went viral. So people really loved this design. They loved the idea. He actually finished it here, and it really didn't cost much to produce something like this. And so it was a really good project. Andrew said the overall scope of my project is fitting several Catan game expansions into one box. My friends, my family, and my wife's family like playing this game. My wife and I are the ones who own this game with this expansion. This means every time we take the game with us, we carry our 4 boxes seen here. This is very inconvenient to us all, especially when it is all for one game. These boxes waste a lot of space. I'm confident that I can put all of these contents into one box, and that was his senior project, and he was able to accomplish that. And so there are a vast majority of things that you can do with 3D printing. It's not just one, kind of a one-track thing. And we're still exploring the possibilities of what can be done. I mean, we're only really limited by our imagination. And I think that's one of the really, really cool things is that there are so many areas which we haven't even touched with 3D printing. And that's why I'm really excited to present this here. It's affordable. We made it affordable for our students. We've made it available. So we've had students consistently using this throughout the semester. It continues to grow. And we're looking to purchase new printers and more development here. So it's been a really good project. I also have a publication that you guys can read, and I'll kind of show you more information and sources that you can look to, because we're trying to condense it down so that we don't cover too much material, but we still kind of get the point across as far as how 3D printing is being used here on campus. So here are some applications and some open source things that you can look at. So for some, you can use Rhino, which is a 3D application used for developing 3D models. We also have 123D Catch, which is by Autodesk. And what this does, it allows you to use your smartphone or your iPad. It's Android or OSA operated, or iOS operated. And what it allows you to do is take anywhere between 20 and 40 pictures of an object. And you're just walking around that object, taking pictures, and it will generate a 3D object for you. And you can export that, and you can use it and print it out however you would like. However, if you don't want to do that, there's Thingiverse, where there's tons and thousands of already created and generated models, which you can share. It's an open source thing, so you're free and clear to use. I have a few models on there myself. Andrew has a few models on there. We also have ZBrush, which a lot of the animators and puppeteers are starting to use now. You have SketchUp, which is another kind of introductory application for developing 3D models. It's a really, really nice application. I've had some K-State faculty use that to design awards, and And it's been a really nice process. And even Photoshop. So we have the Adobe Photoshop here in the Media Development Center, and it will generate 3D models as well, and it will export them as OBJ files. So it's a really cool thing that can be used here on campus. For more information and sources, I listed my publication on 3D and how it's being used in the academic environment. It's also, 3D printing is being used all over. You have biology students who are printing out anatomical models. You also have Braille periodic tables that are being used for students who may have accessibility issues and may need that help in that area. We also have 3D models that can be used with baking. We've had people do molds. We've had people do prototyping. We've done it all. And it's continuing to grow. There are maker spaces being generated. We're hearing a lot of buzz about maker clubs and things like that. And so it's been a really good event. It's been a really good time. But at this time, I want to introduce someone who we've worked with and I've collaborated with here on campus. And it is none other than Dr. Sergio Curto. He is a research associate here in biomedical, and he's in engineering. He also specializes in electromagnetism. And so I'm going to turn it over to him at this time. I'm sure you guys will enjoy what he shares with you all. And I just want to thank you. If you guys have questions, feel free to ask them at the end.
Well, that was a great presentation and very nice introduction, Javel.
Thanks, Sergio.
Thank you for inviting me to participate. And I have prepared a few slides that I would like to show you, so it would be easier for me to show you what do we do in our lab and how do we use the 3D printing. We only have 3 to 5 minutes, so I need to be fast. Let me share the screen with you. Okay, we focus on developing technologies for precise image-guided thermal therapy of cancer and other human and animal disease. And in particular, our main research is on generating hyperthermia, that is temperature between 41 to 45 degrees, and thermal ablation, that is temperature to more than 50 degrees with electromagnetic energy. Okay, and how do we use the 3D printing here? For two of the projects that we have been using the 3D printing is for breast cancer hyperthermia and liver cancer ablation. We usually start our prototyping, designing our antennas and the environment that we are investigating in a 3D electromagnetic software. In this case, we're using CST Microwave Studio. And as you can see on the left-hand side, we have those are the antennas. Then we simulate the breast model, and this is the chessboard. And the cool thing is that with the same software that we design our devices, we can design the part that later on we want to 3D print. In this case, we have the fixture for the face array and the fixture for the breast model. Here we have two pieces that we 3D printed. In the right-hand side, we have the fixture for the breast model, and in the left-hand side, the fixture for the face array. The tissue paper here is not very nice for the photo, but it was a good indicator that our device was waterproof. Here we have some experimental setup. I'm not going to go into detail, but the 3D pieces that we built, they help us to perform our experiments with 4 elements antennas. And then here we can put 4 temperature sensors, and we can monitor the different temperature over time. Then for the liver tumor ablation, it's very important that we design our devices, but then it's very important that we perform the experiments always in a very robust manner. So we design this box. Here you can see on the right-hand side that we have the microwave antenna, and then the box has 2 kind of templates. Here we can we can see the template for the axial cut and then templates for the sagittal cut. This is going to allow us that after the treatment, we can cut our meat in those directions and we can evaluate the ablation that we are creating. Also here in the box, we have little holes that they are guides for our fiber optic temperature sensors. Those are just some examples of ablation and that we created with the antenna using the piece that we 3D printed. And just to conclude, I just want to say that the 3D printing can save you a lot of time because you don't really need to use a dedicated software. You can just use the same software that you have been using for 3D designs. Then you just save the files as an STL file and send it to Javel. And then you can build very robust prototypes and experimental setups. And we know this because we are using very high temperature and we are always working in environment with water. So the devices are waterproof. Then how expensive it will be the pieces depend on the quantity of material that it requires. But in general, they are pretty cheap and inexpensive. For the pieces that I show you in the presentation, I think correct me if I'm wrong, Javel, but I think they were around $12. And I would recommend you to visit Javel and his office. And he had very cool pieces, and he's probably going to give you new ideas on how to do your 3D designs and your 3D printing. Thank you for listening, and please let me know if you have any question, or you can send me an email. Now I'm going to turn back to Javel. Thank you very much.
All right, and I'm gonna turn it over to Shelly, and I think she will facilitate from here.
Yeah, so I haven't gotten any questions over the chat yet, but does anyone out there have any questions they would like to ask either Javel or Sergio at this time? Great presentation, you guys. Okay, I don't see any coming in over chat, but one question I had, Javel, that maybe you could clarify a little bit.
Sure.
How much does 3D printing cost if you come into the library?
Okay, and so that was part of the idea. We wanted to make it affordable for faculty, staff, and students because we know that 3D printing was a very just a couple of years ago, a 3D printer was $500,000, and so we wanted to make it affordable for the students, and so we came up with a pricing chart where pretty much the only consumable price would be the cost of material. So essentially, what you're paying for is the cost of material. So that ended up being around 10 cents per gram. So that's what we determined was 10 cents per gram. And it would be a $2 consultation setup fee for cost of material. So that would cover a lot of the cost of material for printing. Such as like you see this blue painter's tape here and the filament that it's using. And so this is not used for profit. This is not a business. This is just more so for the academic learning, kind of a pedagogical approach. So it's been a great kind of experiment and survey, and we've seen an increase in demand. So I hope that answers your question.
Yeah, definitely. So it sounds like it's very reasonable. We did have one question come in, and
we just finished there.
So how brittle is the 3D material?
Okay, so and that was another cool thing. The PLA is a very sturdy material, which is one of the reasons why we use that. However, since it is so sturdy, I will be honest, sometimes when we have our support rafts, they're a little challenging to pull off. So I use kind of it's like a paint spatula, if you will, to kind of pull that off of there and to break it away from the support and the raft, which worked pretty well. And it usually comes out very clean. You can drop it. I mean, it's something that is very durable. You can make it a completely 100% solid object, or you can make it a 10% infill, which means that it will only be filled about 10% of that object. And you can vary as needed. So if you're worried or wondering about price or want to spend less and still get the same model, that's something that's an option, definitely an option that you can choose.
Awesome. Any other questions for Javel or Sergio at this time?
If you guys give me a second, I can actually pull it off of the printer so you guys can kind of see what printed.
Okay, hey, Javel, how about while you're doing that,
Sure.
since there's no more questions coming in, I'm going to go ahead and turn things over to our next week's presenter so we can kind of do a summary of what's going to be talked about next week. And then we'll come back to you once you have that model ready for us. So at this time, I'm going to go ahead and invite Jerry Snyder to unmute his microphones and talk to us about next week's presentation over MediaSite.
Hi, Shelly. Can you hear me okay?
Yeah, we can hear you great.
Okay. Next week, we're going to be talking about MediaSite, which is a digital media tool for, you have to think of how to use these video. What's the best part of using video at a university? Use it for teaching, lecture capturing, flipped instruction, blended media. So we're just going to go over a good overview of MediaSite. What is MediaSite? How to embed MediaSite videos within your K-State Canvas class, managing videos using MediaSite, sharing your videos to others on K-State campus, and also once you do produce videos, you can actually see who's looking at your videos and how often people have looked at videos. So it'll just be a good brief overview, but it's called MediaSite, and hope you can join us next week.
Awesome. Thank you, Jerry. And I'm going to share my screen really quick. We do have that kind of summary up on our Tech Tips Live website. So if you want to reference that, you can. So now I'm going to stop my screen here. And Javel, are you ready to show us what the 3D printer made? Javel, you are still muted. Sorry.
All right, so here's the model. Sorry about that, guys. And so it's just for practical. And so we start this print maybe 15 minutes before, just so we can get something finished. But you get something like this. This has a 10% infill, and it's fairly durable. I mean, it won't break. I'm putting pressure on this, and you can pull the support raft right off, and you'll have your model. So it's a really neat thing. I don't know if you guys can see that. It's not focusing well, but yeah. So something like that. Done, and hope you guys enjoyed it.
Awesome. Okay, well, I think at this point I just want to thank Javel, Sergio, and also Jerry for speaking up today. I hope everyone can join us next week to learn more about MediaSite. And once again, if you do want to watch the recording of this video, it will be posted on our website. It's tech-tips/ITS/tech-tips/live. So I hope everyone has enjoyed today's video presentation, and we will hopefully see everyone next week. Thanks.
Thank you.